Here's a quick video for the handout number 6. I think someone requested this in class. So if you need to watch it, then you should watch it. So let's just review some basic algebra. When we take the square root with a variable in it, so for example, if I take the square root of x squared, technically it's the absolute value of x. And let me talk about why that is. So, for example, what if x is, let's say, -5? And if I take the square root of x, the -5 squared, you know that will come out to be the square root of 25, which is just 5. So see how we did not get -5? So it's not correct to say the square root of x squared is just an x. A lot of times they'll say in a textbook, they'll say, let the principal root be positive, or let the principal root be greater than 0, then this is acceptable. But if it doesn't say that, the square root of x squared is the absolute value of x. Because again, if it is a negative, you're not going to get a negative as an answer. But if it was a positive, if x is 3 or a positive 5, then the square root of 5 squared does truly equal 5. Okay, so number 6, I'm hoping that everyone's okay with the first step. I think it was the square root stuff that Mr. Lester started talking, and I'm sure it was hard to hear me. So I'm hoping that we're okay with the formula that I applied, found the derivative using the chain rule. And then here's the derivative of x, the derivative of y. Here is me squaring the derivatives. And now we should take a GCF out. And then the GCF is in the blue right there. And then this is what I'm left with. We can do my Pythagorean identity on this. And when I do the Pythagorean identity on this, I just get 1. So let me pick up on my other piece of paper from that part. So here's what we have. Here's the square root, and it's 9 sine squared t cosine squared t, and it was times 1, which I know is silly. So I know that there's supposed to be integrand here, and that there's a dt, and I know that there's 0 to 2 pi. But we can't, yes, the square root of 9, that's obviously a 3. But the square root of sine squared t, that's the absolute value of sine squared t. That's what that is, based on what I was doing on this side. The square root of x squared is the absolute value of x. So, square root of cosine squared t is the absolute value of cosine squared t. And now, I'm supposed to integrate. Here's my 3 that I pulled out. Here's my 0 to 2 pi. This, the square root of sine squared t, is the absolute value of sine squared t. And then I can put it all into the same absolute value, but it's too late now. I just drew another bar. The square root of that is the absolute value. And I think this is where Mr. Lester started talking. How do I, and again without the help of a calculator, how do I go integrate this when my integrand has all these absolute values? So then we decided that to ensure that the integrand always comes out to be positive, to make sure that happens, I want to think about what values of t would make sure that the sign of that comes out to be positive. So if I stay from pi over 2 to 0, or from 0 to pi over 2, I know that the sine and cosine are both positive. So this is what we did. Instead of going from 0 to 2 pi, let's go from 0 to pi over 2. We don't need the absolute value bars anymore, because I know, why do I feel like I made a mistake? I did, I'm sorry. The square root of sine squared t is not that. It's sine of t, and the absolute value of that. The square root of cosine squared t is the absolute value of cosine t. Okay, and again, this is where I am right now. I want to make sure the 2 needs to go away. For me to make sure these two come out to be positive, both of them, I want to stay in the first quadrant. So let me start this again. Here's where I'll write. Here's my 3, here's my 0 to pi over 2. Here's my sine of t, cosine t. I don't need the absolute value bars anymore, because if I go from 0 to 3 pi over 2, I know that this will produce positive values also, only. And so if I go from 0 to pi over 2, here's the shape again. It looked like that, sort of. So if I go from 0 to pi over 2, I'm only finding one portion out of 4. So don't forget to multiply that by 4. I'll throw the 4 in here. And then I was saying that you should do U substitution. Okay, hope that was helpful.